Hi guys, welcome to the what. So today we will see MATLAB simulations on closed loop, non-isolated DC to DC boost converter. Right. So in the earlier video we saw the simulations on open loop boost converter, but now we will see simulations on closed loop. So let's get started. So we know that boost converter circuit will not change. The main circuit and the triggering circuit both will remain same. One additional thing that we are attaching, or one circuit or one closed loop that we are making, is the feedback loop. Feedback means it will take the input from the output that we are getting, and according to it, it will give pulses to the triggering circuit to trigger our MOSFET switch or IGBT, right? So let's see the basics of our feedback loop. So here, as we can see, we have our main input voltage, we have our main circuit with the inductor, capacitor and switch and all, and here we are getting some output voltage, right? So now this is our non-isolated open loop boost converter, right? So now if we see that we are adding this loop here, this particular loop that is known as feedback loop, we are taking the signals from the output voltage, we are feeding back the signals to our triggering circuit, and then according to the difference or according to our reference wave or reference signal that we will provide here, this circuit will give different pulses to our main circuit, right? So this is the main thing or the basics of a feedback loop. Now how to create this feedback loop? So here we are seeing the components that we usually require uh, to make a normal circuit or open loop circuit of a boost converter. We have already seen how to design a boost converter in our earlier videos. The link is also given in the description. So please go there and first make our open loop non-isolated boost converter. Then come back here. So now we are seeing the feedback components, right? So here in the feedback components, it is a very simple feedback loop. The main thing that we need here is the PID controller. This is the heart of our feedback loop, right? And one add and subtract block and one constant. We will use this constant to give our references, right? So let's see how to design a feedback loop. Now we can see here, this is an already made DC to DC open loop boost converter, right? So we have already designed the exact same circuit in our earlier videos. Please do check that as well. So now let's design our feedback loop. So first thing was PID controller. So take one PID controller, take one add block, and take one constant, right? Now how we will place this? So now this PID controller we are using as a feedback, so let's just rotate it, and then we will also rotate this add block. So what is this PID controller basically? So PID controller will give us an output starting from 0 till 1. Its maximum output is 1, right? So it is proportionate, integral and differentiate controller. So here we will only use P and I. We don't want derivative, right? because our work will be done in P and I only. So we'll set a value to 0.0001. This is a designed value, pre-designed value. We will make a separate video to tune our PID controller. So tuning, that means we are deciding the proportional constant, that is Kp, this one, and we will also decide our integral constant, that is Ki. We will also see how to design our derivative component or derivative constant, that is Kd. Right. So right now we only need P and I, and the value of integral would be 0.1. This is already tuned circuit, so I know all the values. Right. Let's apply this. So now the output of this PID controller will be controlled by this input, which will give by using an add block, right? And what will be the reference? Let's keep our reference here. Now the output of this PID controller will start from 0. So like we can say that if this is a graph, and if the input is a type of linear input, then on each and every input our PID controller will give us a linear graph, and maximum it will reach up till 1, right? So this is the basics of PID controller. So according to the input that we will give to the PID controller, it will tune itself. It will give the output in the range of 0 to 1. So indirectly, if we are using this thing in a DC to DC converters, then we can say that indirectly we are changing the duty cycle, right? So our duty cycle will also range from 0 to 1 only. If we convert this whole thing in absolute values, like for 0.2, that means it is 20% duty cycle, right? If we have 0.8, that means it is 80% duty cycle, right? And we have designed our open loop circuit in such manner that this constant value is also a duty cycle value, right? So what we can do here, we can just remove this constant and we can connect this output of this PID controller to this constant value here only, right? So instead of a constant, now we will have a variable value which will come from this PID controller according to the output, right? So now let's connect this thing as well. So let's, here it would be minus and plus. So the output that we are getting from our circuit will be negative. So output that we are getting is this one, right? And here we will feed positive here. So now our input voltage is 100 volts. So let's keep our boost converter setting on 200 volts, right? So that means from outside I am saying to this boost converter that please work on 200 volts only, right? So now let's see what will happen. Let's run this. So as we saw here, the output is constant, that is 200 volts. Let's open the scope. So now here we can see that 100, the blue line is our constant value, that was the input, and this yellow one is the output. Now if we zoom this thing, then we can see it is not exactly a constant, but it is on an average constant, right? At 200 volt, it will increase. Then the PID controller will know that the value is greater than 200, so then it will take it down. And now it will know that it is lesser than 200, so then it will take it up. So this is the basic role of a PID controller, right? So now let's see some more outputs of the same setting, right? So here the output was the voltage. Let's see current output as well. So in current output, as we can see, input current is around 40 and the output current is around 20. And this is true because in a boost converter, the output voltage will increase and the output current will decrease. So that will keep the overall power constant at the input side as well as on the output side, right? So this is correct. Now let's see the main thing, that how this PID controller actually worked. So as we can see on the first graph, the blue line is the output of our PID controller, right? So let's zoom in the whole picture. So as we can see, PID controller is also not constant, but we can see that it is near to 0.51, right? So we can say that it is approximately 51.5 or 51% duty cycle. That is nearer to 50% duty cycle, right? So the circuit decides the duty cycle by itself. We are not deciding the duty cycle. We are just giving the voltage that we required as an output, right? And according to our requirements, the circuit will design itself. The circuit will design the duty cycle itself. So this is the main meaning of a PID controller and a feedback loop in a closed loop transformation or closed loop conversion, right? So now let's try to keep this at 150. Now let's run the circuit. So just focus on this output, right? So now we can see here it is almost 150. So the output voltage is 150. Let's see the output. So here we can see it is 150, right? Now let's see the output of the PID controller as well. So here we can see the PID controller is running approximately at 0.34 or 0.342, right? So it is around 34% duty cycle, right? See, it is 34.18. So it is 34% duty cycle. So according to it, we are getting output that is 150. So now you got this, right? That we are not changing the duty cycle. We are just changing the reference voltage, that on what voltage we need the output, right? So if a thing happen that the input is changing, then also it will try to make the output a constant value that is nearer to 150 only, right? So this is the main advantage of the closed loop circuit that we have designed, that it is independent of the input that we are providing, because it will try to keep this output at 150. So according to it, it will change the duty cycle. So earlier when we saw that if the input voltage is 100 volt and output that we need is around 150, so the duty cycle was around 34%. Now let's see that what this circuit has decided. So now we can see that it is around 47.8%, right? So the circuit will decide itself the duty cycle according to the output that we required. Let's keep this 100 for one amazing thing that we will see. Now we will run this circuit for 1000 seconds. So that means the circuit, for like we are just keeping 1000 seconds. We are considering that this circuit or this particular thing is already in use in an electric vehicle or solar, right? So in an electric vehicle or solar, we are not closing our circuit, and then we are not changing the each and everything. We are changing, or we are like, if we compare the acceleration of electric vehicle to an acceleration of a normal IC engine vehicle. So in IC engine, we are not switching off the engine while we change the speed, right? So if we put pressure on accelerator, so the whole circuit, the whole engine is already in working mode. So this circuit will also also work in similar fashion. Circuit will continue to run, and on that we will change the output accordingly, right? So let's run this. So let's keep 150 um, 150 as a reference for output. So let's run this. So now we can see the output is almost 150. It will fluctuate a bit. Now we are not seeing anything because we have keep 1000 seconds, which is a long time. But here we can see our circuit is going on and on, like it is complete. It completes it 4-second cycle, then it will be on 5-second cycle, right? So now we can see here that our circuit is moving on almost 150 volts, right? The yellow one is the output and the blue one is the input. So now what we will do, we will change this reference to 250 volts. So if once we will change the reference, here we can see we are not stopping the circuit, right? The circuit is on, current is already passing, everything is there. But now we can see that the output is 250 volts. Let's see the scope. So now what we can see here is that initially it was running at 150, as we can see here. But after some time, after we change it, it automatically boosted upwards around to 250 volts, and now it is already constant. And we can see that the blue line is already constant, as this is our input, right? Let's try one more setting. Let's do this to 200 volt. So now we require the output as 200 volt only, right? So circuit is still working. Then we can see here our output will change to 200 volts. Now if we see everything, then we can see it clearly that how the circuit is behaving. Now the yellow one, initially it was 150, then it went to 250 according to us, and now it came back to 200, and now it is constant, right? So this is basically the meaning of a closed loop control, right? So we are not stopping the circuit is on, and then also we can change its output value. Now let's do one thing. Now let's change the input voltage, right? So let's take 80%, 80 volts as an input voltage. We can see there is no difference in the output. We are still getting 200 volts as an output with an input of 80%, right? So now let's see the behavior. Right, so let's zoom it in. So we can see here that at the point where we converted the input to 80 volts, that one jerk happened here, right? So this is due to our PID controller. So like instantly, if some input voltage is decreased, then this PID controller will take some time to tune itself, to manage itself, and after some time it will give us our desired output. So this is important, right? That right, if we see the starting, then it will start from 26.24 seconds, and around it is being constant on 26.36 seconds, right? So if we subtract 26.36 minus 26.24, so PID controller will take around 0.12 seconds to tune itself or to tear itself, right, before giving us the output, right? So this is basically how the output will behave if we change the input voltage, right? So this is a good example of closed loop control. We saw how we are changing the input, then also output will not change, and how we are changing our reference, then according to the reference only our output will change, right? If we see the graph of PID controller, we can see lot of things here, right? So let's check it. So here we already saw that initially when we kept 250, then it initially we kept I guess 150, then the controller was giving something here, then we kept 250, so it went up according to the duty cycle, then we set it to 200, then it went down, and when we are changing the input, then also the duty ratio will increase, right? So then it will increase and it is giving us output. Then we just change our input from 80 to 100, so it came back. So this is basically the working of a closed loop control of a boost converter, right? Let's stop this. So please do let me know if any confusion is there, or if you want any other closed loop control, please do let me know in the comment section, right? And if you want some changes in the method that I'm presenting, then also you can make some suggestions. I'll try to make those changes, right? So that's all from my side. Thank you so much. Bye bye.